Swayam Prabha. Digital India. Educated India.
And then once you fold it, you have the ridges, no? Just mark using your pencil or pen. You now have a ruler. Correct? How many folds matter, no? If you have made 2 folds, you will get a ruler which is 16 centimeters per division. If it is 4 folds, it is, and if it is 8 folds, 3 folds, it is, if it is 4 folds, it is, if it is 5 folds, so 1 centimeter you can have, correct? And if you want to be more, ambitious, you can fold one more time and you will get, very good. Let's quickly do that. Done? Yeah. So mark it. Mark those points, those ridges, so that you have the ruler now available. They may not match with the rules that you have already on the notebook strip. Mark it. Yeah. So mark the ridges, please. Mark the ridges fast. Lunch is now getting over. Done? If you are done, what I want you to do is this. Mark 2 points on your notebook. On a fresh page, mark 2 points arbitrarily on your notebook. Done? I want you to use this ruler and find accurately, I'm using this word accurately, right? I'm qualifying it to be accurately the distance between these 2 points A and B, let us say. Yeah? If you say 10 centimeters, I'll ask you, is it 10 point? I don't know, you tell me. Okay. If it is exact, you move the point a little bit. If you say exact 10 centimeters, 20 centimeters, 15 centimeters, erase that and mark something else which is arbitrary. 9.9 what? 9.9 and then next digit? 14 point. It can be something. Yeah, only a few people can write 5 point something. It has to be something that you have to tell me, no? Yeah, but I want accurately. I am very demanding. I am very demanding. 12.1 what?
4.5.
Huh? 4.5 what?
4.5.
No, I need more digits. No, it's not possible. Ah, come on here. Then why are you here? Yeah, but you can make it more precise then. How will you make it more precise? Okay, try it. How precisely you can measure is the question. Yeah, make more number of divisions, correct? Right? You would want to make more number of divisions. But is there a problem to it? What is the problem? We can't go beyond a certain thing, right? What shall we do? I want more finer, because world is demanding. I give you this, no, I need more capacity, more apps, more communication possibilities, etc., more. So I want more accuracy. What shall I do? 1 mm accuracy possible, correct? Yes or no? Very tough, huh? Okay. Now, what I want you to do is this. Take the other strip. How many of you made 16 divisions? In the first one, how many of you made 16 divisions? How many of you made 8 divisions? How many of you made 32 divisions? Okay. How many of you made 64 divisions? A part of it. Very good, very good. Okay. So 64 is the limit that you are going to 0.5 centimeters. What you do is, whether it is 64 or 32 or 16 or 8, take the other strip, measure till the last division. So if you have something like this, so this is the first strip, you made divisions, let's say something like this, you take the other strip, leave out one division and tear it like this. Earlier it was the same length, correct? Tear it like this, so that if it had 32 divisions, it will have 31 divisions. Correct? Don't do anything else, but just tear it so that the length is known to you. Those who have 32 divisions will have the other strip, which is 31 divisions or 31 length. Those who had 8 will have 7 as the other strip length. Done? Done? Quickly. Yeah, the 64 people would be struggling. 32 may be okay. 16 is easy. Yeah? 8, no problem at all. I have already done that, sir. Don't do anything with that strip till I tell you what to do. How many of not done yet? The second strip, don't do anything. You will have only the length available to you. Okay? If it is 32 centimeters, you have 31 centimeters for the other. Or whatever the divisions are. So far, okay? Anybody who has not done it yet? Okay, all of you have done. Yes? Measure it. See, if you have 32 divisions, measure to 31 divisions and tear off one of the divisions in the second strip. Clear about it? The first strip is already available as a ruler. The second strip, just tear off only one division length, so that it is a shorter strip by one division. Clear? Done? Now fold that strip in a very similar way that you folded the other strip. If it is 32, 16, 8, you do the same thing here. Before you do that, I have a question for you. How many of you know HCF? If you don't know, go back to the school. Okay. Okay, you know HCF, correct? How many of you know relatively prime set? Only a few, huh? Relatively, a set will have two numbers. Relatively prime? No common factor. Very good. No common factor. Give me an example.
4, 9. 4, 9.
4, 9.
Okay.
I can give you 100 in within a matter of 5 seconds.
13, 5.
Because I will say 1 and 2, 2 and 3, 3 and 4, 4 and 5. Correct? Consecutive numbers automatically have to be relatively prime set. Correct? What I have done now is I have a ruler that is 32 centimeters and another ruler that is either 31.5 or 31 or 30 centimeters or 28 centimeters. Correct? Yeah? Depending on the number of divisions that you made. Correct? Now I have two of them which are consecutive numbers like 32 and 31. Correct? Yeah? Or 64 and 63. 8 and 7 consecutive numbers. What do we know about those numbers? Common factor is? If I take one ruler and put the other ruler by the side of it, which ridges will match? Only the first and the last one. Why?
Because they are relatively prime.
Relatively prime. Correct?
No common factors.
This was what was proposed by a French mathematician back in 16th century. Correct? So what I did was basically this. Correct? Now I have this and I have this. I know if I had done this division, none of these divisions will match except this one and this one. But fortunately, if I take one as reference and slide the other over there, I will now be able to get more accuracy. Now you have power. Yes or no? The same distance between the 2 points, you will now tell me with more accuracy. Yes or no? What will you do? First ruler you will put from one to the other. The second ruler you will slide in such a way to find out where it is matching. What do we call that instrument?
Vernier caliper.
Wow, see, look at that. And therefore, our man Vernier did not invent vernier calipers. He invented relatively prime numbers. The importance of mathematics and the connection that was made. Beautiful, no? Now, power to me. I can measure more accurate distance without having to keep on folding, line. No. I can now do this. Beautiful, no? Fantastic, right? Think of it. If I had to do finer lines, it would have been very tough for me. He made it very simple. Vernier made it simple because he proposed relatively prime numbers. Years later, somebody said, okay, now let me use these two rulers and rule the world of measurement. Yeah, that's the beauty, correct? And then came one more way by which, right? I don't want to go into details because of time, but it is like looking at a wedge and the height that you can cross. Why do you have ramps? In the buildings you have seen ramps, no? Why ramps? What is the length of a ramp compared to steps? Very long, no? Why? So if I have lower angle, I will have longer length, right? That's the principle of screw, by the way, right? So they came up with the screw gauge, which is more accurate. Not enough. Man is never satisfied. Correct? So I did this on PowerPoint. You can easily draw lines, no? And then copy and all those. I did 100 lines, right? And I did 99 lines, stretched them like this. One had 99, the other is 100, right? What I am now going to do is vernier caliper, but a little bit more. What is that? I pulled it down and started moving it one over the other. Can you see this end is moving? More than that end, you can see something moving. Can you see that? A band is moving. The band is moving faster compared to how this is moving. Correct? Yeah? This is vernier caliper, right? I actually have done for a higher resolution. 500 of them. Okay. Crazy. Okay, let's see what happens. Yeah, look at that. Very small movement. But you can see the band moving, which means you know there is a movement. Right? Power to understand that there is movement or measurement that is possible. Correct? But then I had to do 500. You can see 500 divisions there? No, it's some hazy stuff. Correct? I want to do more. What shall I do? Vernier caliper is not enough. Screw gauge is not enough. What shall I do? Then came one more beautiful invention, beautiful connection. You like this connection? I already told you what it is. Okay. So I have the ruler. I'm going to now make these lines. For example, one is a darker line and then lighter. Okay. If I do on all of them, this is the same as this ruler. Correct? Where the intensity is high and then low, and then high, low. Yes or no? I can do it like this. Yeah. Now I can do it like this. Right? What is it? Intensity high, low. High, low. Is it a ruler? The answer is yes. Correct? From this, I can also do this. What is this? And therefore, I can now say ruler is equal to wave. Right now? But what's the advantage, sir? How many of you know what is wavelength? Again, you have to go back to school if you don't know. Correct? Now, can I have wavelength that is very, very small?
Yes.
Smaller than the divisions that I can make?
Yes.
If it is so, and I showed you this thing and there are bands forming, the same band will form here.
Yes.
What are they called? They are called interference patterns or fringe patterns. Correct? It is the interference that we saw as bands moving. Right? You can do it by yourself. Right? Now, again, I have one more power, which is I can use sound waves. One sound wave, very small difference between one wavelength of sound to the other. And I mix the two. What will I get? All the musicians will tell me immediately, beats, right? If I do it not on that wave, but there is some other wave that I know, which is sound wave is there. What other wave do I know? Ocean wave. Okay, what else do you know? Light wave. Light wave frequency is now higher. Wavelength is smaller. I can go smaller and smaller and smaller based on whatever light that I choose. Now power is very high. I can use interference pattern and mix two lights together of very small change in wavelength, and now power to me, I can use wave interference. Do you know today we have laser interferometers. Laser is another invention that was helpful in terms of making it sharper. Okay. Laser interferometer. Last year my colleague bought nano interferometer. What is that? It can measure nanometer. Now they have gone to angstrom also. How many of you have heard of LIGO? LIGO. Scientists wanted to measure gravitational wave. Gravitational waves are very, very long. What they did was make an observation on 1 kilometer long testing equipment. 1 kilometer. So they did this 1 kilometer in order to measure gravitational waves and the birth of LIGO. Type LIGO and you will get it. Measurement of gravitational waves was never thinkable earlier. Wonderful, no? Who started it? 1 year. Right? Invention after invention changes the whole world, and therefore we get inspired. We get inspired with so many inventors. The one who invented needle which did not need anything else, a sellotape that did not need a pair of scissors. I get inspired. This inspiration is very helpful in terms of persisting on something that I will do. Okay? Since I'm short of time, I'm just going to go express way. 7 habits. Can anybody remember the first one? Okay. The second one? Observe, identify solutions. Third one? Building proper intuition. The fourth one? Yeah. Fifth one? What existed before? Ask. Sixth one? Day-to-day activities. Connect. Scorching sun. You'll remember, right? The last one is get inspired. How do you get inspired? Learn the story. Right? Not necessarily only Einstein and Newton. Right? It's not that everybody has to be scientist to invent. Who invented the aeroplane? Somebody who was in the lab? No. There is no necessity. There is no connection. Look at this. Invention. How about this? Solved a problem. Luggage as well as sitting. Solving problems, yeah. And look at this one. Cooler catering to 2 rooms now. And this is cool. Onion cutting. Our Indians are famous for jugaad. But let's not stop with jugaad. We go further, okay? Somebody came up with seat belt. This is a beautiful one. A farmer wanted to sell, this is pomegranates of various sizes. But I need to now separate the sizes. Look at the beautiful way that he has come up with. We learn from these. Uh-oh. Just two rods, just diverging a little bit was enough to separate. So you would put one, two like that instead of looking at them all those. Over. You could separate. Right? Jugaad. How does it happen? I need to keep being persistent. Very important. I want to end with this. A visitor went to a construction site where a temple was being built. Usually visitors will ask the workers, right? The first worker the visitor encountered asked, okay, what are you doing? Sir, I am laying the bricks and putting the mortar. Oh, very good, very good. And then he goes to another mason. Ask the same question. And that mason actually was holding a weight, right, and measuring something. Oh, what are you doing? Oh, I'm building a wall. I want to make sure it is straight up, vertical. Oh, wonderful. Okay. And then it goes to the third one. Ask the same question. Visitors usually ask the same question. All right. So ask the same question, and this time the answer was very different. He said, "I'm building a temple, because of which I'm now building a wall of a room, for which I had to lay the bricks." All the three were doing the same work. Who is better? How many of you want to be inventors so that you can build the temple instead of laying the bricks? Right now you are laying the bricks, sitting and doing the work, etc., etc. Nothing wrong with that. But what is it that you are doing it for should be clear to you. All right? Whether you want to be inventors, whether you want to be scientists, they are not very different. You want to be engineers, right? Please remember this. And therefore, dear Masons, what are you? Inventors, correct? Ask that question. And where do you start? Where do you start? Moms will not like it. You start with kitchen. For example, silly putty is not available. What will you do? You will take some chapati flour, make sort of silly putty out of it, correct? Kitchen. Where is your lab? Where is your lab? The whole world is my lab. Beautiful, no? Wright brothers did not need a lab to invent something. This is something that is hit into our brain, put into our brain that you need a lab. World is a lab, right? And folks, sky is no more the limit today. You can go far, far beyond, and therefore future is bright. Even if I live up to 90 years, I know I'll enjoy a lot of technology that you have built. Yes or no? Thank you. And this is me. I'm usually called Anbudan Shiva. That's what I sign off with. I'm right now hot on duty as far as my department is concerned. They also call me head of the department. Department of Applied Mechanics and Biomedical Engineering. Now, all my coordinates are given. I have written 2 books recently. One is called The Progress Mindset. The other is called From Struggle to Strength. Both completely based on my personal experiences. What I have not told here is what research I do here. I've been here for 3 decades so far. What research do I do? Any guess? Close? So I do in a broad sense mechanics of materials, The specific one is smart materials. How many of you want to learn smart materials? Smart materials. Materials, for example, one smart material that I can think of is when that gadget is touching the hot surface, it will just pull off the hand, and that object is called human. Right? The smart material there is the tissue, the muscle. Right? There are so many materials that are possible to use in the smart structures or devices. I work in that area. If you are interested, let me know. I'll conduct a separate lecture on that. Again, it will be a session where it's completely experience based. Okay? Any questions? One or two only because time is short.
Sir, you told me explain about the clay.
Look at what is happening. Is this a solid or a liquid? It's flowing here. It is flowing. So fluid? Yeah, if it is fluid, I can take it out and then make a shape. It retains the shape. Right? So, definition of solid and fluid is fluid. Yeah. Any other question? Any other question? Quickly. This is just a clay. You can use chapati dough also to do the same. Yeah, it is neither solid nor fluid. Any material cannot be directly defined by solid or fluid. It has a time constant. Okay. They say the glass panes of church in Greece, the cathedral church glass panes are thicker at the bottom and thinner at the top because glass has flown. Right? So, all materials can be both. Yeah. I have one series on fun with materials, by the way. Yeah. Any questions? Any questions? Wonderful. Thanks a lot. So, raise your hand. Raise your hand. Wonderful. Turn it like this. Pat your back. Because it has been 4 and odd hours that you have been sitting with me patiently. So, I am very happy about it. So nice of you. Thank you.